Okay, so in the last video we talked about how to draw a budget constraint when you're given a total amount of resources to spend, whether that's time or money, and then the price or amount of time cost to produce units. In this video we're going to be looking at how the budget constraint can shift around or change shapes as some of those factors change. So what happens if your income changes? What happens if the price of one of the goods changes? Yada, yada, yada. So this is the graph. On this screen is the graph from the last video with Pop-Tarts and Diet Coke. And so the question is, what happens to this line if I get a raise? So in the previous example, my income was only $300, and now I'm going to get a raise to $400. So the question is, what's going to happen to the budget constraint? So remember, the way we calculated the intercepts before was to take our income and divide by the price. So these 2 points tell us how much we could get if we spend all of our money on Diet Coke or all of our money on Pop-Tarts. That's what the two intercepts mean. Let's see. Let's see, 30. Okay, so the vertical axis here is Diet Coke, and the horizontal axis is Pop-Tarts. Okay, so the question is, what happens if my income goes up to $400? What's going to happen is, if I spend all of my $400 on Diet Coke, instead of 30 cases, I can now afford 40 cases. If I spend all of my money on Pop-Tarts, I'm going to get $400 of income divided by $6 per box, and that turns out to be 66 2/3 cases. So that would be, let's see what the scale is here. It goes by 5, so it'd be somewhere right around here. And we get a new budget constraint there at that red line. So what we get is income changes create a parallel shift in the budget constraint line. So if your income increases, the budget constraint is going to shift outwards. You can see there are more points now in the feasible zone, in the feasible set that we can reach, because we had more money to spend. Notice that the slope hasn't changed, because remember, the slope of a budget constraint is negative px over py, and neither price changed yet, so the slope is still the same as it was before. Okay, let's look at an example where your income goes down. I think that's what's up next. Okay, I want you to go ahead and try to figure this one out. I'm going to give you a second, and then so you can pause it and then try to figure out. I'm going to put the answer up here. So if, remember, draw. The price of Pop-Tarts was $6. Price of Diet Coke was $10. Pop-Tarts, Diet Coke. Okay, so if I spend all of my money on Diet Coke, I'm only going to be able to afford 15 cases. If I spend all of my money on Pop-Tarts, I'm going to be able to afford 25 cases. Oh, that's not 15 though. 15 is here. So anyway, now my new budget constraint is this line. So when your income goes down, you get a parallel shift inwards. My feasible set is now this area in here. It's much smaller than before because I can only afford, I can't afford as much of the goods because my income went down. Okay. I think next we're going to look at what happens when the price of one of the goods changes. Oh, yep. It's like I wrote this or something. Okay. So same deal. We're back up to an income of $300. So back to the default scenario. That's what the budget constraint on the screen is. But let's assume that the price of Pop-Tarts goes up from $6 to $7.50. Price of Diet Coke stays the same. Thank God. Okay. So if I spend all of my money on Diet Coke, I'm still going to be able to afford I'm still going to be able to afford 30 cases. So I'm still going to be right there. However, it's going to change. If I spend all of my money on Pop-Tarts at the higher price, I'm not going to be able to afford 50 cases. I'm only going to be able to afford 40 cases. 300 divided by 750 is 40 cases. So now my budget constraint is going to look like this. Because one of the prices have gone up, I did lose out on some of my feasible set. I have less options to choose from. And notice that the slope changed here. The original slope, remember, negative px over py. So the original slope was, we've got Pop-Tarts here, Diet Coke. The horizontal good is Pop-Tarts. So originally the slope was 6 over 10. The new slope is going to be... This stylus is interesting. Anyway, so now the new price is 7.5 over 10. Negative. They should both be negative. So it's going to be a steeper slope. All right, so I think the next one is going to be a change in the price of Diet Coke, and I'm going to put that up for you all to try, and then I'll draw in the solution. Okay, so why don't you give this one a shot? I'm going to pause it and draw in the answer. All right, so in this example, the price of Pop-Tarts stayed the same, so my intercept on the Pop-Tart axis is the same. It's still at 50. 300 divided by $6 is still 50 cases. The change now is going to be on the Diet Coke axis. The price of Diet Coke went down. Sweet. And so if I spend all $300 on Diet Coke, I can now afford 40 cases, which is right here. So our budget constraint shifts up. Notice we added this area to our feasible set. When a price goes down, that's good for me. So it makes me better off. I have more potential bundles to choose from. We're going to see why that's good for us in the next few videos. But anyway, this is the way the budget constraint would shift. Right. I think I got some more examples for you. So this is looking at a case with a curved budget constraint. So this is one that shows diminishing returns to time. So we're back in the situation where we're on the island and we're getting fish and coconuts. So our resource is time. So we have diminishing returns to time in this situation. So we're not going to be able to come up with exact values on this graph because we don't have the equation. I think it was in the previous video, but so we're just going to show what the shifts should look like in general. So for part A, we are going to modify our assumptions and say that instead of working all 24 hours a day every day to harvest fish and coconuts, we're going to sleep for 8 hours a day and only spend 16 hours a day on harvesting different foods. So when that happens, remember what the axes represented here. Let's see. I think this one was coconuts and this was fish. So this represents the point if I spent all day catching fish and no time getting coconuts. So if I'm only spending 16 hours a day instead of 24 hours a day, what's going to happen is that I'm going to end up being able to catch less fish than I was able to do before. Same deal for coconuts. So if I only spend 16 hours a day harvesting coconuts and instead of 24, I'm going to end up harvesting fewer coconuts in 16 hours. So you get what is analogous to a parallel shift inwards of the budget constraint because you're spending less total hours harvesting. Okay. Part B, reset the graph. How does it change if you figure out how to make a net, increasing your per hour fishing yield? So this is analogous to the price of fish going down. If you think about the hour you spend fishing is the price you're paying. What's happening is that for each hour, you're going to catch more fish. So if I spend all day fishing, I might end up with I guess that's 45 pounds of fish. But since the net technology doesn't affect coconuts, if I spend all day harvesting coconuts, I would still end up at the same place for coconuts. So the amount of fish I would get if I spent all day catching fish would go up, but it wouldn't change the intercept on the coconut axis. It would just raise the intercept on the fish axis. I'm going to erase some of this. We can do part C. Oops. Okay. So part C says, how does the graph change if all the coconut trees suddenly grow giant thorns, reducing your per hour yield for coconuts? So this would be analogous to the price of coconuts going up. So thorns on the coconut trees don't affect the amount of fish you would get if you spent all day fishing. So the intercept on the fish axis is going to be the same. But now, because of the thorns, even if you spend all day harvesting coconuts, you will harvest fewer of them. So the shape would look something like that. All right. We've got some examples for you to do on the next one. Okay, so I'm just going to put this up here. I'm going to pause it. All the answers are on the next slide. So why don't you go ahead and pause your video, try these 4, and then I'm going to switch over to the answers. Okay, so pause and work, and then come back. Welcome back. Here are the answers. They're color-coded. Part A is in red. Part B is in blue. You can read. If you have any questions, bring them to class. And last but not least, here are some page numbers from your textbook. This is where the textbook explains all the stuff about budget constraints, and then there's a practice problem from the book if you want to do that. All right, I'm going to switch it back to the answers here, just in case you still need to look at them. Otherwise, talk to you later.